Hi, myself Mercelin Lincy. My project title is Advanced Encryption Standard Implementation using Null Convention Logic S-Box. My project guide is Mr. Danand Jain. Now let us see the hardware demonstration for this project. This is the Ultra D0 FPGA kit which I am going to use in this project, and it is said to be wired to a LCD display. I have connected this FPGA kit through a USB blaster to a laptop, through which we can dump the program to the hardware kit. Yeah, it consists of an LCD display, 7-segment display, FPGA, and this red button is the on and off button. Now let us see the software program for it through the Quartus simulator. The Quartus software is said to be programmed with the tool to be dumped into the hardware. Here you can see that the plain text which is given in the form of the numbers. So now I have already compiled this program. Now I am going to enter into the programmer. When the programmer is clicked on, you can see a window which is displayed. Here we will set the hardware for to be dumped on. The hardware setup will display a dialog box where hardware, which is the USB blaster, will be selected. Then the start button will be clicked. Here you can see that the progress, which is 100%, will be shown when the kit is ready to be dumped. Now here you can see on the hardware. Here you can see the initial display, which is the AES cryptography. This is a plain text which is given in the number format, and when another button is kept on and the reset button is set, we can see the encrypted text which is obtained, and when another button is kept high and the reset button is activated, we can see the decrypted text which is the number which we gave initially, and when another button is made high, we can see the NCL S-Box, which is the asynchronous output. That is, it is a time dependent independent output which is obtained. Next will be the NCL inverse S-Box output which is obtained. Now we can see, now I will demonstrate the input which will be given in the form of a letter. When a new input is given in the Quartus tool, it should be saved and should be compiled. Here you can see the compilation process which is carried on for the new given plain text input. The compilation process shows the number of logical elements, which is 248, which is used in this program. and the combinational functions and the dedicated logic registers and the total number of registers and the pins used for it. Now you can see that the compilation is said to be successful. So similarly, we'll go to the programmer option and we'll click on the start button in order to dump into the program. Here you can see the output, which is the AES cryptography. When I Here you can see the plain text output, which is given in the letter format, which is the 16 values. When I change the value, then now we can see the encrypted text which is obtained for it. Now you can see the decrypted text which is obtained for the given input. Similarly, we can see the NCL S-Box value and also the inverse S-Box value. This is the full hardware setup of my project. Thank you.